Hello, people of the internet. We should be good. We should be live. We should have our Android giving us video and audio, and then we have Haley joining us on the top right of our screen. She's going to be here for the next foreseeable future. We've actually changed the schedule of the live streams to jive with her schedule. Now, in the past two live streams and the ones that were recorded on the site, I had Hannah joining us, who was the guy that gave us the contract on the freelancing marketplace. He was a novice programmer, and that's kind of the same pitch that we have here with Haley. Haley is actually not a programmer. She doesn't have any experience. So her questions and her dialogue should be very enlightening, and she's going to be rewarded for helping me out with these streams. Now, the reason we're doing this offline recording here right now, today, on the 24th of September, is because there was a problem with LiveEDU. It was not saving the live streams that were being cast into the project library there. So we're going to do this offline recording. They've managed to fix that bug. I'll be here today after this is uploaded for 4 more live streams, and Haley will be joining us. We'll be here until 1 o'clock local, our time, in the morning. And we'll be doing lots of live streams. We'll be doing 6 a week, hopefully, or 8 a week, actually, 4 at a time for the next foreseeable future, Monday to Saturday. Today's Monday. Haley? Yeah, so today's Monday. At least we figured that out between us. Today's Monday. We're going to work on how to build a trading bot in Bitcoin, or rather, a Bitcoin trading bot in, let's close Facebook, in Node for BitMex. Now, we've already done a whole bunch of these live streams. I actually did this these 3 sessions here at the bottom. I actually did them on Saturday, this past Saturday, but they weren't saved to LiveEDU. So, what we're going to do is we're going to start with the first session. We're going to use the API to collect current and past prices using candles on BitMex. So we're actually going to use 2 different libraries. Now, so I should tell you, Haley, basically what we did so far is we did a whole bunch of different steps to get the code to where it is. Basically right now it's just giving us a graph. Like if I was to run it right now, I'm pretty sure it'll work and show me exactly what I've done so far. And you can see my screen, correct? Yep, sounds good. So we're going to run this code. It's going to take a couple seconds here because I actually just decreased the amount of resources for my virtual machine because we're not going to run Linux and Windows at the same time, and because it was taking too many resources. So if I go to the website that was posted by our app, basically this is what the app does right now, Haley. It's just going to give us this graph here of nothing because we don't have any data for it, and it's going to give us this log of information here at the bottom every time I refresh the screen. It's actually doing stuff that I don't want it to do right now, stuff that's involved in this first session. So what did I break here? Oh, I'm in the wrong folder, I think. There we go. So we just ran the full code. We don't want to do that. We want to run our little pieces of code that we had ready before the live stream that never got posted. Now, I had about 40 people in that live stream, so it's a good thing. What did I break? I have a function here that's trying to be called. This is the line of code that just broke. It's trying to call a function that doesn't actually exist. So let's make that function. Let's just make it an empty function. Now, Haley, you've never done code before in the past. That's correct?
No.
No. So basically, all of this is nonsense. So basically, I'm making a function here called fetch OHLCV, and that's just the name of the function. I made it an async function because we're going to call stuff in the background to run asynchronously. Basically, the coding language we're using is called Node. It's a server side of JavaScript. And right now you see my graph does nothing. There's no log. That's exactly what we expected to see out of the partial code that I had ready by the end of the last live stream. So let's just go back to OBS and make sure we're still recording. Everything's fine. Looks that way. I can see Haley. I can see myself. Let's make Haley bigger. Whoops, I muted you. Can you hear me?
Yeah.
I muted you by mistake a second ago. So actually, I moved you on the recording. I'll give you the recording number done, Haley, and I'm going to give you a subscription to the LiveEDU by the time I'm paid my first pay, just so you can see what we're doing and reference back to it. Now, if you wanted your friends to see, that'd be great. We only have 1 subscriber so far. I'm very happy for that 1 subscriber, but we've had over 1,600, I think, views. Yeah, 1,604. Look at that. Very popular, very fun. All right, let's go back to the code. So the very first thing we're going to do, again, is collect that data from BitMex. Now, we're going to do that using 2 different libraries. So BitMex, Haley, because you have no idea what that is either, is a Bitcoin exchange. Basically, they're one of the biggest ones. They let you do leverage. So this is all covered in the other live streams. You can catch them up later. But for your own knowledge, BitMex is an exchange where you can buy and sell Bitcoin. You can do it using money they loan you, called leverage. And you could actually do that up to 100 times. So you could basically invest $1 in Bitcoin, and they'll give you $100 to play with the Bitcoin on the exchange until you sell it. So what else should I tell you? Yeah, we're going to use two different libraries. So basically, for the bot to work, and what we're doing today, Haley, is we're creating a Bitcoin trading bot using like an algorithm, like an indicator. The one we're using is called price momentum. Basically, it measures the volatility or the movement in price over the last little while. And we're going to do it over 12 intervals, so 12 minutes, as well as 24 minutes and 36 minutes. So really, our bot just sees, and I can actually show you this in a graph on TradingView, what this looks like. Our bot basically sees if the price is moving up or down over the last, I guess, 36 minutes. It confirms it to see if it was still moving up or down in the last 24 minutes, in the last 12 minutes. And then if it's moving down for 36 minutes in a row, continually over 12 and 24 minutes, it'll just sell that asset. And if it's moving up over that interval, it'll buy that asset. So basically, if the price is moving up, it's going to buy. If it's moving down, it's going to sell. So I'll show you what that looks like on the graph. So here's the price of Bitcoin and US dollar over time on our exchange that we're looking at. And I just tried to rename that. I don't want to do that. You can still see my screen, right? Haley? Okay, so here's what we're doing. We're going to use 3 of these indicators. One of them is going to be on, and we're going to do this through code, but this is just to visualize what it's going to look like. We're going to use 3 of these indicators over 12, 24, and 36 minutes. So we're on the minute-ly graph right now. So here's the price of Bitcoin in US dollars over time. Can I move this? Whoa, not what I wanted to do. Technical difficulties. All right, whatever. Let's just move Haley back up to this corner. So here's the price of Bitcoin in US dollars over time. It's something around $6,000. It's been going up and down over the last little while. But really, what we're looking for in our indicators here is if the price has been moving. This is not a good example. So over this period here, from here to here, it's been moving up for about 36 minutes. We can see because each of these bars is a minute worth of activity. So if you take a look at this indicator at the beginning and the end of that swing, you'll see that it's over is 0 here. So 0 is the middle of this graph. If it's over 0 here and over 0 here and over 0 here on our 3 indicators, it's just going to buy Bitcoin. So basically, if the price has been moving up like it did from here to here, it'll buy Bitcoin at that point, somewhere around here. And as we can see, that was probably a good move until we went to go sell it up around here. But our bot's going to sell it as soon as it goes down for 36 minutes in a row. So our bot's not that smart, but we're not really concerned about profitability here. We're just trying to code something that does something. That's all we're doing. So I need my function. It's an empty function. What we wanted to do is pull the last 36 minutes of data from a historical database. So we're going to use the library CCXT to do that, which is a universal library among Python and Node and a bunch of other different programming languages. I think PHP is another one. So we're going to use CCXT. We're going to pull prices using a CCXT function called fetch OHLCV actually. And OHLCV, all that means is open, high, low, close, and volume. It's basically the candle or the cline for that period. So it includes all the data. If we go back to our chart here, that one of these little bars indicates here in the candles. So basically where it entered into that minute, where it exited that minute, the lowest price, the highest price, as well as the volume, which we don't see on this graph because no, the volume's right here. So the volume's right here. So however much is being traded is going to be indicated there. The only thing we really want from our candles or our OHLCV is the closing price because that's what we're going to use to calculate all the stuff we need to know. That being said, let's figure out how to do that. We want to pull the data from CCXT. Now, it's a good thing that I already did this stuff and it wasn't recorded because I had a whole bunch of problems getting the right data in from CCXT. When you call this function here, let's put it in our code actually, hold on. Let's just grab all of this from here to here. Okay, So here's the code that we need. Here's the code that's going to pull the historical data. And the reason we're doing this, Haley, is because otherwise, if I made the bot to just use real-time data using like the API for BitMex, then it would have to wait 36 minutes to collect all the data it needs in real time in order to use the functions that we're going to code later to figure out the logic of the bot. So by pulling in the last 36 minutes over the last 36 minutes that happened, basically we can run that code to see if the bot's going to enter or exit into a buy or sell signal. And we don't have to wait 36 minutes for it to update with real-time stuff. So the reason we're using CCXT to do that is because the BitMex API doesn't really give us that information directly. So CCXT has it's like a layer on the API that allows us to pull that information from them because they collect it and store it. That being said, the function that we're looking to do that is this one here, fetch OHLCD. And we don't actually have exchange defined here, I don't think. I think we do. Whoops, Control F. Hello, code. Yeah, we do. So here we go. Exchange equals a new BitMex instance, and we're using an API key and API secret from the real live BitMex server to pull this information in. We're going to do it on the Bitcoin US dollar pair. And it's actually kind of confusing because CCXT calls it BTC/USD, even though BitMex calls it XBT USD. And that's going to cause some issues later, but we'll figure that out as we go along. So has anything I said made any sense at all as somebody that doesn't know how to code?
Yeah,
Oh, I lost you. I lost you, huh?
I'm just writing down words I don't understand so that I...
Yeah, well, let's go over that now. What do you have so far?
I don't understand what an API key is.
So the API key basically is our access to get into the private functions that the API allows us to do. So an API is an application programming interface. It's usually a service that sits on top of a site or like Facebook has one. Facebook has one to do all sorts of stuff with pages and your profile and stuff. Whenever you see people that are bots on different sites or platforms like Instagram, they're all using an API to do that. So basically an API lets you build code that interacts with the site or service or platform. Ours is going to interact with BitMex, but there's APIs for everything. There's APIs for Facebook, there's APIs for Instagram. There's some APIs that exist that people have coded on their own to interact with the platform because they don't release their own one, like Snapchat. So there's different ways you can use Snapchat that Snapchat doesn't really like you to do, but you're able to do if you do enough snooping and figuring out to use a personal or a custom API. So that's what it is, an application programming interface, and all it means is that you program stuff to interface with the application to do stuff. So if I was to make a simple Facebook bot, I could make one post like a word. Like you've actually seen stuff on my Facebook that is exactly this, and it's just testing, posting images or text using an API. I'm not hearing you.
It said something that was like CC something.
Yep, CCXT. I don't know what it stands for, but it's basically an interface for using different APIs among different crypto exchanges, like Bitcoin exchanges. So it's a platform that is this, and it lets you use all these different crypto exchanges, and they do a whole bunch of other useful stuff. So in our case, we're using them because they have the last 36 minutes of data that we need to get the bot to figure out the logic of whether or not it's going to buy or sell. So the only reason we're using CCXT is because they have those 36 minutes. Now, I could do other stuff. I could create a database, for instance, that pulls in the real-time information that we run all the time and separate from our bot. But we don't want to do that because that's a whole bunch of extra code. We could just use CCXT and the libraries they have and the services they provide to pull in that data, which is what we're going to do right now. So all of this code here does that. Go ahead.
What is when you first started, like when you break the section of the code, I guess?
Yep.
Like, how do you do that? Like, why is it, how is the section, how is it structured?
So yeah, code, I mean, this is kind of a requirement to get in here, but because you're new to this stuff, I'll tell you. So this function right here, from this open bracket to this end bracket, is a specific thing that we can call at different times to do different things. So functions inside, basically you have your stuff up here, which is requiring libraries to get this all to work. So other work that other people have done are going to make our lives a lot easier. They're going to allow us to do different stuff. Like that web server I showed you earlier is all this Express stuff. So somebody wrote a whole bunch of different stuff we could take advantage of that we're only using a little tiny bit, like that graph that I showed you. That's not even doing anything right now. And so all of this code is explained in the previous few live streams. But basically, we're setting up our libraries that we're using, our API key and secret we have coded in here. Our BitMex client here, this one is actually the live streaming one that we're going to use to pull in live data. Some of this code, so all this code that exists without an open bracket is going to be run whenever the program first runs. So this one here with an open bracket only gets run when we call this function, but we do that anyway right here inside the code that gets run at runtime.
So the ones with no what?
No open bracket. So you see this bracket here from here to here?
Yeah.
So this means that this is contained within this fetch OHLCV function, meaning this code from this bracket to this bracket only gets called when this function is run. So there's other open brackets here too, like this one, this one. This says if this is true, meaning if our exchange has the function fetch OHLCV, which we know it does, but just in case it didn't, this code would not get run. But it does in our case, and it's going to get run every time. We could actually just remove this, to tell you the truth, because it's not even necessary. It's extra code that's just slowing us down, and it's still going to run exactly the same. There's some other stuff here, like this for loop here. This goes through this code for every time that there's a variable called candle that we're calling it inside of the candles variable. So we saved a whole bunch of stuff to candles here, and I could actually show you what that looks like inside the log. So let's run this code again, and I'll show you exactly what that looks like. So we were saving all this information inside the candles variable, and then that loop of code, that for loop, is going to loop through it all and save only a specific part of it. I think the closing price is what we're looking for inside of a. So here's our candles variable. It's all of this stuff. So for every one of these instances inside candle, we're going to loop over this code. So really the code is going to look at this, and it's going to go through this as many times as there's code or variables within that candles variable. So it's going to go through that like 20 times or whatever for each of these that exist. 36, I think, is exactly it, because we told it to consider the last 36 minutes worth of data. And it's going to do this code here within these open and close brackets over and over again. So basically all we're doing in this code is we're pushing the fourth element of these candles, which is 0, 1, 2, 3, 4, this number here, which is the closing price, which is again what we're using to train our to tell our bot what to do. So the only thing that we're interested in all of this is this fourth value, which is the closing price. And what the closing price is, Haley, if we go back to our graph, the closing price, it's hard to tell with this graph. Basically, I wonder if I can find a good example. So here in this bar here, in this 1 minute of data, we have a high price up here of whatever that is, a low price of way down here of whatever that is, and where it exited that minute or where it stopped the action or like what it was worth at the end of that minute is right here along the middle. So that's the closing price for that minute, which is what we're going to use to see if our bot can enter or exit into the signals, if that makes any sense. So we're gonna save that into an array or a list called list3. I just named it. I don't know. I had 3 lists at one point, but then I realized I only needed 1, and I still kept that variable name, which is not a good thing to do. You should always make sure your variable names make sense. But in my case, this list3, I made it. I declared it somewhere up there, and it's saving that closing value of the candle. Our last price, I'm not sure why I'm saving. I think I'm doing it for the, no, I'm not sure what's being saved there. No, the last, what is that? I don't know why I'm saving candle 5, but we'll figure that out later when we look at the other code. Go ahead, yep.
Why is it candle?
What?
Why is it called candle?
It looks like a candle on the graph. It's really funny. It's from a long time ago when they first started trading stocks, like thousands of years ago. But basically, because this looks like a candle, if you look at a good example of one, you'll see that it looks like a candle with a wake on each end. Like this one here, you see that? It's got a wake on each end. Yeah, it just looks like a candle. That's the only reason it's called a candle. Look at Bitcoin go. Look at this price change. It's gone up like $40 in the last minute. $50. Anyway, that's not important. What's important is the bot. So we're saving the candles. What we're saving in the list 3, and we can actually go and log our list 3 to show you what's in it. after it's done being created, after this for loop, and rerun the code, it's going to show us the closing prices for each of those candles that we saw in the code right here. So if we just wait for the code to re-execute here, it's just going to take a second. I had to lower the resources for my virtual machine. Yeah, that's a very good question. So it's just because it looks like a candle. It's just funny in the way that traders talk. And this is taking a really long time to do the stuff that it's supposed to do. Why is it taking so long? Oh, I broke something. I know what I broke. Hold on, I know what I broke. List 3 is actually not declared. So we have to go ahead and make our list 3 every time we run this function. And it's just going to be an empty array. That's the error message that we got last time we ran our code, is that it didn't know what list 3 was. Sorry, what was that, Haley?
You typed in momentum. Is that a website or?
Oh, the momentum there that I typed in was show you these indicators here at the bottom. That's how our bot is going to have logic to see whether it's going to buy or sell. So momentum, and I explained this in a previous live stream, all momentum is, you see where this is moving up, this momentum?
Yeah.
So that's over the last 12 minutes. So basically, what's going on? From here on this graph, 12 minutes, it's saying from here to here, right down here to up here, the price of change has moved up, right? So it's moved from negative to positive momentum. So because the price change is moving up, and it's moving up even more over these 12 minutes, from here to here, you'll see that the momentum is even higher. So all momentum is doing, just a second. All momentum is doing is telling us that the price change is either positive or negative. So the change in price over the time period. And the time period, again, that we're using is 12 minutes, 24 minutes, and 36 minutes. So you see that the change in price over the 12 and 24 might not be the same. It might be positive in one and negative in the other. If it's positive in one and negative in the other, our bot eventually is going to decide not to enter into a trade. That's the whole point, is that it's only going to enter a trade when it's been positive for a little while, and it's successively positive. You see here that the bot is actually giving us the closing prices from our list 3 array that we made earlier, which is exactly what we want. That's what we want to feed the monster, feed the bot here. What did I just do? We want to feed it these closing prices to see if it wants to enter or exit into a trade. Yeah, do you have any other questions? There's lots of stuff in here. You can feel free to ask anything.
Okay.
I mean, lots of this makes no sense to me too. Like, I know what these. I don't really know what a promise is. I know it has something to do with an async call. I don't know what resolve is. I don't know what any of this stuff is. I know that what this piece of code does is say it must set some of this other stuff somewhere else. Basically, it's saying let's sleep, and we're going to wait sleep later, which means we're going to wait that amount of sleep time. Basically, when we await sleep, we're going to wait exchange.rate limit milliseconds worth of time before we make our next call to the API. And all that's saying is the API, which again is the application programming interface, is forcing us to wait a certain amount of time in between each calls, or else it might get exhausted with a whole bunch of successive calls from different people, and stop being as responsive. So we have to wait their mandatory amount of time in order to make our next call, which is why that code's there. But do you have any questions about what I've said?
Why are stuff like the blue? What?
Yeah, and that's just because I actually went over this in a previous live stream. So we're using a program here to look at our code called Notepad++, and that's just a Windows program that you can use that'll highlight code, and it's just basically a better Notepad, which is why it's called Notepad++, which is actually really funny because the reason C++ is called C++ is because it's a little bit better than C, which was the first programming language that came out. And inside C and C++, and actually Node, to tell you the truth, we can do a counter. Like if you had a variable, you could go A++, and that's going to add 1 to A. It's just going to be like 2 if it was 1. It's just a funny way of saying that C++ is a little bit better than C, which is the same way as saying Notepad++ is a little bit better than Notepad. So anyway, Notepad++ does a whole bunch of useful stuff, including making some of the words blue. The blue words are basically if you're using part of a programming language, like Node in our instance, to do something. So when we're making a function, or when we're making a variable, or we're letting something be a variable, if we're doing a for loop with variables and the keywords like in, it's just highlighting the keywords here to make it more understandable and more legible for when you're coding. It's just helping you out. It's doing stuff for numbers too. Like it just highlights everything to make sure that you know what you're doing. And I mean, the only real benefit of that is if you look at Notepad, like the original Notepad, which is this is building on. If I had all the code in here, it doesn't do any of that syntax highlighting, which means that all of this stuff looks the same, and it's harder for me to tell what the difference is among different things. Right?
Yeah, I get that.
Okay. Very good questions, man. This is going to be a lot of fun, I think.
So you take stuff right on the notepad and put it into that website?
Yeah. So this here is our command prompt in Windows. So we're actually just running the code using the program Node. So this file here is app.js, which is what we're running here in here. And then what happens after this runs is part of the code is telling it to put it to a web server. And I was actually explaining that. That's the express.js that we included at the top there. And we're saying whenever you get the root of the website, show this HTML. So it's basically combining a bunch of different programming languages. So we're telling the Node server, which is running here in command prompt, to give us whatever's on we tell it to on this website here. And by the end of these sessions, we'll have a graph of the profitability against the Bitcoin price percentage difference over time, as well as output from our code. So to eliminate that, what I could do here, I have a variable that I explained in a previous message, or a previous session, and I think it's just called log. Yeah, it's just called log. So if I was to go ahead and tell my log variable to include list3, it's going to go ahead and show at the end of this web server in this little area here that I have for logs. So this stuff that's outputting to the console right now, I just told it to add that to the log, which is going to show on our website. Just because I have it down here in the code to do that, it says message, like the final HTML is going to be whatever we have in the graphs and stuff, plus that little log. So as soon as it runs here, I'll show you what that looks like. As soon as it runs, man, I'll show you what it looks like. Unless I broke it. What's going on here? There we go. So now if I run this website again, you'll see that the log includes that list of prices, which is what we just added to it. So that's the only thing, is that we're telling the code to do a couple different things. We're telling it to output stuff to this console here using console.log, which is this one right here. So it's logging to the console. And then when we want it to log the website, we tell it to do stuff with this log variable that I created. So we added it to the log, and it's adding it to the website. At the very end of today, Haley, or the very end of the first little project today, we're going to add that graphing functionality in this last session here. To go ahead and include basically just an indicator of whether our bot is profitable over time. We can't even do that, unfortunately, because I have no balance on BitMex. So because I'm poor, because I have no money, there's a zero balance in BitMex, which means that my BitMex API key is erroring out whenever I try to do stuff. So we're not even going to be able to really do the last session. We'll do the Bitcoin price over time versus US dollars on the minutely candles. But we can't do our balance because, like for instance, if I try to divide 0 by 0 to get the profitability over time for the balance, it's going to give me not a number, which is not going to graph. And we'll explain that as we go forward in the next sessions. So really, this first session, we're up to 28 minutes. This first session was using APIs, collecting current and past price candles, klines in Node. Candles are the same thing as klines, as far as I'm aware. I think they are. So the next step here in our code is going to be to pull the live data from the BitMex API. So what we're going to do then is use some of this code, because we don't need some of it yet. We're only going to do that after we pull the old data. So we're gonna use this add stream. We're gonna look at this Bitcoin price over time and pull the 1 minutely data from the BitMex API. So client here, we've already described that above. Our client variable is a BitMex client, which is the real-time API plugin here that BitMex provides, and it's going to give us real-time data every minute. The problem with our bot, and the reason why it wasn't profitable at all, is because for each minute, it's giving us information 15 seconds after that minute is complete. Meaning that all the other bots in the world, all the other bots that have strategic partnerships with BitMex and all that fun stuff, can get that information before we do, act on it faster, and get that profit before we can get it. Again, the idea is not profitability, but rather to get a bot that does stuff. So we'll continue on. So right now, I just added this code here that's going to pull in this minutely data. Let's see what that data looks like. by logging the data and running the code again. So then it's going to run after we pull this last 36 minutes worth of data in, and it's going to get us the most recent information here from the server. So what I just did is I added the 1 minute trade box stream, and we pulled that from the server. It got the most recent one. If we wait a minute here, let's see what time it is. If we wait 15 seconds, it's going to pull in another minute lead candle in real time, 15 seconds after the minute has completed, and it's going to log that here. As we can see inside our code, we have a whole bunch of different useful stuff. I think my niece is trying to come in the room. Hello, Reggie. I'm doing work. Can you go away for a bit?
Can you?
I think Mom has it. Okay, good stuff. Sorry about that, Haley. And everyone. I love you, Reg. Are you there, Haley?
Yep.
Okay.
I think I was in your screen now.
Oh yeah, I think you did. Let me call you back. Let me let me call you back. And we're having technical difficulties with Skype. So let's see what happens here. But we see that we've been pulling in minutely candles ever since we created that code. It's pulling in more candles as we speak here in our console log. Here in our console log, man. Here in our console log, man. And what we're again interested in is the closing price here. Hello, Haley.
Hello.
Hello. So let me change your screen. Hopefully it'll be the same size as my video. Sorry?
Like this, when you start coding, when you start making a bot, I guess, you open the Windows thing first or the Notepad?
Yeah, the Windows thing first. So the Notepad thing is inside the Windows thing. Now, I could do this all on my computer, like my computer without the virtual machine. It's just that the virtual machine allows me to do stuff in an environment where I know where everything is, where everything's set up properly and works, separate from my own operating system. And it also means I can run virtual machines that don't even use the same operating system that I'm using. So I could run Ubuntu, I could run Mac, I could run a whole bunch of other different Linuxes, even Windows 7, Windows XP. I can do a whole bunch of different stuff with different operating systems inside these virtual machines. That's the whole point, really, is that they're encapsulated little things where they can run any operating system.
Okay.
So you know when I use an Android and I don't have like images on Snapchat and stuff, it's because I'm using an Android emulator on the PC to get a virtual machine of Android.
Okay.
Just because I don't have a phone and like I don't have a Linux computer, so I have these Ubuntu VMs to run Linux on this computer.
So you can have your computer on Windows and run Linux using that?
Yeah, exactly. I can have a Linux environment within this little window here using virtual machines. Or this Windows 10 one.
So how do you like submit your bot? Like how do you like?
I mean, it's running right now. So as soon as we get it to in the next sessions here, we'll code it to actually do trades and stuff. And that's basically all that needs to happen. It's just going to run locally. It's going to pull the information in like it is right now. We can see, and then it's going to act on it and do the orders on the local machine. Later, what I'll do is something like this. I'll use Git, which is a package repository or a repository solution for code. And I don't have a Git repository in this directory. So later we're going to put it on this Heroku server. So you see this web address here on Heroku, which is this platform here. So basically we've built the code to work with Heroku because Heroku, like for instance, their internet connectivity is like 100 times faster than mine. So I'll set that up right now and walk through how to do that. But basically what we want to do is we want to use Heroku, which I've installed in this virtual machine, to push this code. And all this code does here, this stuff that I'm entering in the console, is what's going on? What did I do? That's not what I want to do. So we have to clone it. Okay, so what I'm doing right now is I'm grabbing what's on Heroku and putting it into a folder on my local drive. And then what I'll do, and we'll do this all at the end, but I mean, we'll as well do it now too. So I'm going to grab the files that are inside of our bot here. I'm going to throw them on the folder we just created. Oh, it's still being created. My internet is not the greatest. And I might have just broke it by putting files there. I don't know. I might have just broke it. Anyway, so what we're doing to, it's called deploying the bot, by the way. We're going to deploy it onto Heroku by using Git, which is a program that allows us to push files and folders into a repository, which basically keeps track of the changes. So if I was to make a mistake or break my code, like for instance, LiveED was broken earlier today, I couldn't stream, which is why we changed the schedule, why we have time to do this offline recording, and all that fun stuff. Basically, some developer made a mistake, and then to fix the mistake, all they did was in their Git or whatever package repository they use, they rolled back the changes to something that worked. So it keeps track of every change that you make, and you can actually see the logs of changes. You can actually change it to a different commit, which is a different point in time. You can actually see everything that's going on. What's going on with my window here? Okay, well, Git's not working right now. I don't know why.
So as soon as you start typing stuff in, it starts doing it?
Yep, it's just running commands that we run. Because it's smart like that.
Every time you hit enter is when it...
Yeah, exactly. It's when it submits something. That's just a console. That's how consoles work. You can run any program from here. It's like that's inside Windows. So here I ran ipconfig, which is just a whole different kind of program. It does different things. So it's telling us our local IP address here. It's basically what people use it for. There's a whole bunch of other stuff you can do in console with any Windows command that exists as a console program. You can actually run GUI programs from the console. So any program or any command you can run from console in Windows will allow you to do different stuff. So right now what we're doing is the Git stuff. So
you type it in your notepad to go into the command prompt.
Basically, yeah. It all runs at once and it's all included in a file, but we run it from the command prompt. It basically uses Node, which is how we run it, node-app.js. We're telling Node to run this file. So we're feeding the file to Node, and Node's figuring out exactly what to do with it because it's a programming language. It knows all this stuff from like variable stuff that the console doesn't understand. But we're telling the programming language to run it and do everything that we need to do. So what I'm doing now is pushing this stuff to Heroku. But yeah, what else?
So what else did you use Node for?
Node does a whole bunch of different stuff. So all it really is JavaScript that's on a server and interacts with you by running a local server. And all JavaScript is the one of the oldest programming languages that exists to do stuff with websites. So when you run it on a server, you get a whole bunch of other benefits, like you get to be able to use package libraries instead of including files in your JavaScript, which means you can do stuff on the server. You can actually use interfaces like Express we're using in our code in order to. So we're deploying the bot right now, by the way, putting it on Heroku, like I just said. Anyway, so Heroku is building it, and we can see as it does stuff here. But yeah, so basically Node allows you to do a whole bunch of different stuff, and then there's other programming languages that allow you to do kind of the same stuff, just in a different way. So you use different code, you do it a little bit differently, you use different libraries, and basically each has its own benefit and disadvantage. We're using Node really because it's easy to do, it's easy to understand, it's much easier to type than like Python or other languages, and it's one of the more recent and updated ones. So there, we just pushed the code live to Heroku. So our code right now, as it stands, is now on Heroku, which means I can visit this website where Heroku put it, and you'll see that the log that I updated earlier to include that list is actually updating with that list on this website where we put the code. And it's going to act a lot faster than our code could locally, and it's also going to act all the time, even when I shut my computer down.
So earlier you said local host, and then you gave like a number.
Yeah.
That's your IP address?
That's the IP address for any computer when it's trying to access itself. So the IP address 127.0.0.1, it stands for localhost. It's like the home or local IP for every computer or every device. And that's just a trick that people know to access web servers or things that are running on a local computer. The IP address that you have on your network, you can get through. So here's on my regular computer. This is not the virtual machine. If I run ipconfig, I can see my address is 192.168.0.8, which means that on this local network here, 192.168.0, that's the local network. I'm the 8th computer connected to that network in sequence. So IP addresses are just the way that the internet maps connectivity to different devices. And for every device everywhere in the world, 127.0.0.1 or localhost as a host name will get you to that whatever that device is doing for itself.
So if I typed it on my laptop, then it would.
Yeah, you could type it in your laptop, but you're not running a web server. So what you could do is you could actually use a program called Ping, which is basically sending a transmission to a website. So you could ping google.com and see how long it's going to take to get responses from Google. So you see my ping to Google is about, meaning the round trip time it takes to get data to and from Google is an average of 43 milliseconds. But if I was to ping localhost, which is my own machine, you're going to see that it's immediate. It's less than 1 millisecond to get data to and from your local host or your 127.0.0.1. Now, if I ping my router, it's going to take a little bit longer than that, but less time than Google.
So Ping is a site, not like a site, but
command.
What do you call it?
It's just a command inside Windows and Linux and a whole bunch of other operating systems.
Okay. So Node is like.
Yeah, Node is just a different command. Node is just to run the code using the Node programming language. Ping is to ping stuff and see the amount of time it takes to get data to and from something.
Okay, so when you ping something that's asking for a time like between.
Yep, which it's just going to give you all this information here, which is it's going to send a bunch of different pieces of information to a server. So in our case, we use 3 different servers. We use the router, our own local host, and Google. And just see how long that round trip is. That was just an example of how networking works and how IPs work and stuff, and your local host in 127.0.0.1. That's actually not really that relevant for this stuff, but it is important to know. But people should already know that coming in here. But you don't, I guess, so it's okay to explain it. We have 5 minutes. Do you have anything else to ask?
Markup code is HTML.
HTML is one kind of markup code. The stuff you do on Wikipedia is another.
So what kind is this? Is this HTML?
No, this is not even markup code. So markup code means you use plain English and surround it in stuff. Like if we were to look up the well, you know how Wikipedia works. So when you surround a word in like the word bold or whatever, I don't really know how it works, but that's basically how it works. It'll bold that statement. And our code here is Node code, basically. It's code that only Node understands. It does it in a certain way. Like if you were to have, for instance, if this was Python, all this stuff would be different. Like the keywords would be different. This would be def and then a function name in Python. So you see that everything's different, and it's just giving the code and framing it in a certain way and building it in a certain way and having the open and close quotes and stuff in a way that Node understands and can do the stuff that you're telling it to do.
So at the end where it says verify and deploy, is that like something that you typed in or you hit enter and all that stuff?
It came out, yeah. This is output from the command that we entered. So it means that all this stuff was stuff that the command figured out to tell us what it's doing. To tell you the truth, what we could do for the last, no, I guess we can't. I guess we will do another session. I was thinking we could cut it short right here in an hour, but we still have to do the last 1 or 2 sessions to do the rest of the code, because all we really need to do to fulfill the requirements of the live stream or the contract that I had to deliver was about 5 hours. So we're around 5 hours now, or just under 5 hours. So we'll do another whole hour-long session, and then after we upload these 2 videos and start the live stream schedule for today, we'll be on in about an hour and 20 minutes for about 2 hours, and we'll be back to do another recording. Then we're going to be live streaming all day. Thank you, Haley.
Yeah.
So we're just going to close the recording.